Dr. Najwa Aaraj from the Technology Innovation Institute will share insights on privacy and verification in the AI era. As CEO of one of the region's leading research institutions, Dr. Aaraj's work is helping define the future of secure AI systems. Welcome, Dr. Aaraj.
Good morning. Good morning, everyone. Thank you very much for having me here. Before starting to sound the alarm on the security and privacy of large language models, allow me to introduce to you what we have done in the Technology Innovation Institute in terms of advancing the state-of-the-art of generative AI and large language models. TII has been one of the first institutes to offer large language models as an open source resources with the mission of democratizing AI and having those models at the benefit and the deposit of the majority. Starting from May 2023, we have started with the contribution of the Falcon Large Language Model series. These models have topped leaderboards and they have topped whatever existed in terms of open source models and have come very close to the performance of the closed source models as well. And as the time progressed, we have continued to contribute to these open source models. We have continued to improve the architecture, to improve the fine-tuning, to improve the quality of the data and the size of the data. So what you see over here is the timeline of these models, starting from May 2023, moving into May 2024, where we have contributed Falcon 2. Falcon 2 existed in terms of a large language model as well as a multimodal models, and it was one of the first ones that have been contributed in the open source, has been trained on 5 trillion tokens, and also topped the leaderboard. At the same time, we have announced the Falcon Foundation, moving into August, where we have contributed the first large language model based on the new state-space machines architectures. The Falcon model today is being adopted by the larger community, and we're continuing to contribute models that you will see as an announcement starting from the end of this year going into the first half of next year, models that are focused on this improved architecture, on the improvement of how we process data and the quality of the data, models that are focused on basically including a larger amount of data in the training and a better fine-tuning. We are focusing on the modality, we are focusing on the multilingual aspect of the models, we are focusing on the quality of the data, as I mentioned. One big aspect that we're focusing on today is how are we going to increase the adoption of Falcon, but also the adoption of generative AI models as a totality, and putting them as a great tool for useful use cases for the society and for multiple verticals. And this is where you see our focus to integrate this model in the wider ecosystem, whether for a variety of platforms, whether for compatibility with multiple types of platforms, multiple types of models, being optimized for specific hardware, and being combined and integrated with productivity suites. So that is all in order to enable verticals enablement, whether we're talking about healthcare, whether we're talking about financial applications, whether we're talking about legal applications, image classification and identification, etc. In addition to the work that we're doing on the fundamental models and the LLMs, there are 3 aspects that we're taking into consideration, and we think these are very critical in order to increase the adoption of these models. One, there is the reasoning aspect. there is the safety aspect, and one very important consideration to increase this adoption of models, in particular as models get hosted by cloud providers and technology providers, are security and privacy. And this is what I would like to focus the next 10 minutes on, to show you what we have been doing in terms of looking at the security and privacy of large language models. So if we think about what are the problems when it comes to AI privacy today, there are many problems, of course, and if I may summarize them, I can summarize them in 3 categories. The first one is the one that is related to privacy and inference privacy. And this is what you see here called query leaks. So every time that the user must send their query, they're sending it basically to the cloud provider, which is hosting the model. And at every single query that is sent, regardless of how good the prompt is, there is a risk of creating a privacy breach to the query and to the data that is included there. This means that besides the risk that exists, as those risks are more and more exposed, as the news of those risks and leaks gets more and more in the media, this will challenge severely the adoption of large language models. This will challenge the adoption in the private sector, as well as personal applications that will process private data, including healthcare, financial data, and other data. The second problem that we have is on training. And here, this is what I refer to as the data leaks at the training time, or the training data leaks. As we know, for a large language model to be good, to be of high performance, there is a large amount of data that is needed. Besides the risk of leakage of the vast amount of data, there is the additional complexity is that data is distributed across various entities, it is collected from various entities, and the governance of this data will differ. So even the homogeneity of collecting this data is not the same, so basically it is quite diverse, and there is a very big leak risk, let's say, when this training happens. So even if traditional methods such as federated learning today if they don't have the privacy-preserving aspect, this risk always exists. The third one is, today, when you have the API and you send your query, I can bet that most of us don't have the tools, don't have the means actually to verify that the model that is supposed to send the response is the model that it claims to be. So this sort of verifiability is one of the biggest risks today that we have as we access, as we prompt, and as we try to get responses from those large language models. Fortunately, on this part, there are some cryptographic constructions that are related to verifiable compute or to verification methods that can allow to do that. And the question becomes, which provider is actually willing to integrate those verifiable computational methods at the cloud side? So the bad news on this is that what we know today as cryptographic methods and cryptographic constructs are really not effective when it comes to looking into privacy of inference and privacy of data at the training time. The good news on the other side is there are 2 techniques that are known today in the cryptographic community and that we see that are being adopted more and more that have the potential to solve these problems. The first one is FHE, which is short of fully homomorphic encryption, and the second one is multi-party computation, or what we call the MPC. In short, FHE, the way it works, is very different than how traditional cryptographic methods work. FHE, instead of having this key exchange or having the public-private key infrastructure and then the data gets encrypted in communication and in storage, the way it works, it homomorphically encrypts data. And in order to do any sort of processing, including sending queries to do the inference on it, the data can remain encrypted. Now, this is this is work that has started, or this line of work has started in 2009. There are lots of methodologies that exist today. As you can imagine, a lot of them, they work on integer, they require on encoding fixed bit arithmetic, so they become quite ineffective when we're talking about real numbers and complex numbers. But there are two methods today that are ideal for complex and real numbers, that they use packing and actually can be used with convolutions, and they can be used with transformers as well. And these are the ones that you see here, and these are the ones that we're adopting in the frameworks that we are developing at the Institute today. So what this requires, of course, is it requires that the host of the model, or the cloud provider, to enable the model to be homomorphically encrypted. And once you have the model to be homomorphically encrypted, all the queries can be processed along the same way. They can be sent encrypted. The cloud providers and the model provider, they don't need to decrypt the model in order to send you back the queries. Today, we have achieved a big improvement on this, even though let's say the area of fully homomorphic encryption is still slow. It still needs a lot of accelerations, both from an algorithmic level and from a hardware acceleration level, but these systems exist. We have tested them on CNNs, we have tested them on RNNs as well, and we have tested them on LLMs up to a specific size of the 7B, and there is a very big movement in the community to make those schemes to be more effective. What you see here is our framework. This framework today has been deployed on phishing systems, so phishing detection systems that we have implemented, and cancer detection and medical images. So these are actual applications that we are using with FHE, that we're working with cyber let's say, clients and hospital-related clients in order to deploy these systems. The other method to look into how we can make inference private, or how we can tackle the privacy issues when it comes to inference, is called multi-party computation. And in fact, some of the models that you see out there today are starting to implement these methodologies. The concept of multi-party computation actually is pretty straightforward. The way it works is that instead of one entity, which is the host of the model, getting access to the entire query, this query gets cryptographically distributed on multiple servers in the middle, and none of them will have at any point of time access to the entire query. So you see that here, the data never comes except at the originator in its entire form for somebody to actually have access to it and leak information. Of course, the deployment is something that has to be discussed with the cloud provider. The intermediate nodes, or the nodes that get parts of the queries, that get part of the data, will have to be a contribution of a combination of assigned from the public network, and then another one that is assigned from the cloud hosting. MPC, by its nature, is more computationally efficient than fully homomorphic encryption. It exists in the type of multiple circuits. Some of them are more effective for linear construction. Others are more effective for nonlinear constructions. And they can deal with different types of neural networks and transformer architectures as well. A main contribution of what we have done today at TII, we have availed in the open source as well, along the same philosophy of open sourcing that you will hear from my colleague later today as well. It's called the FANG network. And the FANG network, what it provides multi-party computation framework for neural networks and for large language models. So I invite you also to explore this tool and then see how it can help with hosting of the models, and then with also the deployment of these Gen AI-based systems. So this is when it comes to privacy of inference. This is when it comes to the, let's say, data leak issues or data leak risk when it comes to queries. Then we have the other side of the equation is how can we use those constructions like fully homomorphic encryption and multi-party computation when training. So this is actually to look into and to mitigate the risk of privacy of data during training time. I believe a lot of you would be familiar with the concept of federated learning, and the concept of federated learning today exists. It exists, I would rather say, in a simplistic form, either doing the average over data or doing the max of the data. And by its essence, the idea behind federated learning is that you have different nodes or different entities or different parties that are training the same model, and then these models are contributed back to a centralized agency or entity where they do the aggregation. However, in its traditional form today, multiple risks exist. One is we have the privacy risk with respect to the final model, meaning that the final aggregated model may still leak data if privacy-preserving schemes are not integrated in it. The second risk is the privacy can actually exist, the privacy risk can actually exist based on the risk that occurs on the local models themselves, meaning that information about the training data can still leak at the local nodes themselves. And then finally, it is how can we trust the federated learning participants, because some of the federated learning participants can be rogue, and then they can also contribute models that have not been trained with the right data or that have some sort of poisoning. When it comes to privacy with respect to the final model, the main risk here is that data extraction risk, they exist within this final aggregated model. And traditional methods exist that are actually quite efficient. They may reduce the utility or they may increase the latency when it comes to inference time at the end model. And this is where it comes to adding noise to the model and to the model weights at the aggregation nodes. The main risk, I would say here, that we have when it comes to federated learning is the privacy when it comes to the local models. And again, this is where we explore methodologies and cryptographic constructs and protocols like multi-party computation in order to add the privacy and the security layers of federated learning. So here the concept also is pretty simple, is at each of the local models, the weights of those models are actually distributed in a multi-party computation way. So each one of them, they split the models, they split the weight of the models, and the way the aggregation happens is on the parts of each of the weights from the different models. So you get the aggregation at a trusted node. However, none of the local models will have access to the weight, neither to the data of where the localization of the models happen. And then finally, when it comes to trust at the participants, this is where we use methodologies to compare against an image. So if you think about how we can vectorize each of the models, similarities with images like cosine similarities, etc., can be calculated, and then if there are very big deviations, these are flagged, and then the model contributed from each of the nodes will not be taken into consideration in the final aggregation. This is, again, one of the works that we have been pursuing at the Institute. We're also hoping this is something that we will be open sourcing for the benefit of the AI community and the benefit of the security community. And what we are doing here is we're providing a tool that's called PetalGuard. And what PetalGuard does is it provides this privacy-preserving way to do federated learning and to aggregate n-party models that are coming from local nodes. So if you think about cases where we need to train a big model on data from hospitals, however, there's a very big hesitance from those hospitals to contribute the data. What PetalGuard as a framework does, it allows each of the hospitals, without sending out the data, without, let's say, sharing the data with any other hospital or the center aggregator, to train on the local model, process it through this multi-party computation Petalgard framework, and then the centralized entity, without having access to the totality of the data and the totality of the model, will generate a big model based on this aggregation as if it had access to the entire data. I think it's a bit complex, but this is the means that today we can use a large database of data without actually having to aggregate the data in a centralized place. Before I conclude, I would like to leave you with a video that shows it more from a practicality and use case basis, and I will be more than happy to discuss it with you offline if you have any questions on what we're doing on the privacy and the security of LLMs and AI models in general.
The rapid evolution of artificial intelligence will lead to exponential growth in the next decade, with direct impact in new paradigms such as smart cities, smart manufacturing, e-health, autonomous driving, among others. However, this growth is fed with data. It takes vast amounts of data to train large machine learning models, which can be scattered among countless entities and protected by diverse privacy regulations. Also, the massive size of large ML models makes deployment on the user side unfeasible, thus pushing AI to the cloud service paradigm, forcing users to send private data to the cloud. This has fostered an unprecedented interest in privacy-enhancing technologies applied to machine learning such as differential privacy, generative models, fully homomorphic encryption, and multi-party computation. Big corporations such as Meta, Google, Intel, or Microsoft have fueled research on efficient private AI, and TII has recently joined this race. TII has developed an open MPC platform for machine learning. It enables private federated learning among different entities. Model aggregation is secret shared, protecting each entity's dataset. TII's platform also allows private classification using neural networks. Users can benefit from cloud-based AI without relinquishing privacy. The MPC platform is optimized for machine learning algorithms. It's equipped with efficient protocols for convolutional layers, matrix multiplications, and neuron activations. It also counts with hardware-accelerated, fully homomorphic encryption to pre-process MPC computation. It allows the full separation of the MPC pre-processing from the online data processing, enabling a separate set of entities to run the FHE engine. TII's platform provides native integration with databases and existing machine learning frameworks. It will be open source and publicly available for the AI community. TII will continue working towards a more trustable and private AI.
With this, I would like to thank you, and I look forward to discussing this more with you. Thank you.